Let's get started. I would like to introduce KYZEN's own Kevin Buckner.
Thank you, Sherry. I appreciate that. Today's talk is what you need to know about flush-mounted component cleaning. This is the ins and outs of surface tension. So really, let's see, what is surface tension? Well, surface tension is the tendency of liquid surfaces at rest to shrink into the minimum surface area possible, which allows objects that are typically heavier or denser, if you will, than water itself to actually float or slide like an insect or a razor blade. They will actually float or slide on top of the water surface without becoming even partially submerged into the water itself. So surface tension it's the tension of the surface film of a liquid caused by the attraction of the particles that are actually in the water itself. The attractive forces in the water form, well, it's a type of skin, if you will, to keep the rest of the water from actually spilling out. And then, of course, gravity is going to hold the whole thing to the board. But that skin now becomes actually quite an issue for us. So to measure that skin, we use something called contact angle measurement. And we calculate the size of the droplet. And this helps us determine if the droplet will or will not get under the component that you're actually trying to clean. Of course, the lower the contact angle, the less pressure it takes to force it underneath one of your components. That becomes very important. So let's come a little closer to home. When we talk about washing clothes, water has a relatively high surface tension on its own. So you need something to break down that surface tension. In washing our clothes, we use detergents. Part of the job of laundry detergent is actually to reduce the surface tension of water, and this allows the laundry water to actually penetrate the clothes and improve your cleaning. If water had a naturally low surface tension, then much less pressure or much less detergent, would be needed to wash those clothes. Another situation, there's a disadvantage. The disadvantage happens when you want to make a fine spray of water, as with a water sprinkler. The surface tension being higher means that more work is needed to break the water droplet down into smaller droplets and actually get that water to flow out of the end of the nozzle. If the surface tension was lower, you could run a hose on a lower pressure. So how does all that apply? Well, let's look at some details. So deionized water alone has a height measurement, if you will, of 74 dynes. So DI water with chemistry added shrinks that water droplet down to about 32 dynes. So if your standoff height is running about 3+ millimeters, water and pressure or impingement could work for you. But if your standoff height is 3 millimeters or less, you need to start thinking about adding some type of chemistry to assist you with your cleaning. Now, added to that, the maximum seated height of a typical QFN runs somewhere between 0.35 millimeters and 2.1 millimeters. So to clean the flux from under these devices, first we need to reduce the chemistry droplet size and then apply some type of impingement, which is spray pressure, and we try to create flow paths that solubilize the flux residue. So we have to break down the outer layers of the flux on the device and then force our chemistry under that device, and then we can solubilize the resin-rich environment underneath that device. Now, I happen to like this type of design. This type of design is what they call a window pane design. They offer cleaning chemistries a better opportunity to form those flow channels and obtain a better cleaning experience. As you can see, you have more opportunity to get that flow going through all different areas from underneath that component. The next thing I cover is solder mask. And when you're in the design stages, you have to consider what mask you're going to utilize. There's two opportunities here, which is non-solder mask define, and that's where the solder mask has actually been pulled away from the metallization itself. That gives us a nice place to get our chemistry in and start getting that flow path going through. The second one is solder mask define, and solder mask define, the masking will actually come up over the metallization itself, which not only restricts the solder flow, it also restricts the flux travel as the flux would move out between those two. Now, typically between those two choices, I would go with the non-solder mask removed, but there is a third choice, and that is actually no solder mask. But typically nowadays, this is not an option when you're designing or manufacturing a printed circuit board. The last factors that you really need to consider when you're cleaning underneath low profile devices is going to be pressure and nozzle type. We always refer to different types of nozzle types and how the arrangement is put into the machinery itself. Typically, there's a fan style nozzle, just as it says. It creates a flow of water. It breaks the water droplet size down a little bit, about 15 degrees out, and then there's a coherent spray nozzles. And the coherent is a single jet, if you will, that goes straight down onto your board itself. The ability to clean will depend on the surface tension of the water chemistry solution that you're using, and then with the added pressure or impingement delivery of that chemistry, you find yourself working into an actual cleaning solution. So if you've been fortunate enough to attend one of our KYZEN workshops, we always refer to TEST. And TEST stands for time, energy, solvency, and temperature. When we talk about time, we talk about belt speed in an inline machine, impingement time, how long it's in that particular segment, and then dwell time. Dwell time normally refers back to a batch machine as to the actual wash cycle time itself. Energy is going to be how the cleaning solution is actually applied to the board. What type of nozzles do you have? How that mechanical energy works for you, and the PSI, the pressure, the impingement, if you will, and the flow that you get coming out of those devices. We then talk about solvency. Solvency is the chemistry side and concentration. We hedge bets, of course we do. We know what people use. We know what the manufacturers are making. We test all of those, and we actually start building a cleaning process for you before you actually even get going on the work going on inside your facility. And then, of course, temperature. Temperature is actually very critical because temperature, some of the additives like defoamers that we add into our product, they don't actually activate until they hit 125 degrees. So that needs to be one of your considerations when you're working on developing some type of process. So this is just a reminder that we do a lot of these tech-to-tech sessions, and my associate Jason Chan did a fantastic one on does water do the job on its own? This is low standoff, tight pitch cleaning and its help. If you would like to review that or one of the many other programs that we've done, please just refer back to KYZEN.com tech-to-tech. With that, my time is up. I'm going to turn it back over to you, Sherry.
Great. Thank you, Kevin. If you would like to discuss this topic further, please contact your local KYZEN representative or send an email to tech@KYZEN.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.
Thank you.